long did it take you to develop your OTS to get it to a level that you were happy with the training the operators were getting?
I would say we probably have been at that system or at that level for a number of years. As long as I've been with Husky, I'd say probably 5 years from the recent, I guess, update in our familiarity with the system. So making sure that all our data is correct, making sure all the updates have been made to the simulator, as I think most people kind of connected with that know that maintenance of the system is an integral part, and it can fall off the radar for a while. So I would say probably 5 years is the period of time I've been working with Husky on this system, and we're at that point now where we've got everything to a functional level we're happy with.
Thank you. And just a follow-up question: how much time do you have to spend on keeping it up to date as you have changes in your plants and different settings?
When we've nailed that down, I'll get back to you. But yeah, it's just that MOC process, that good communications. We do have a current process in place now where our project engineering are involving us as a training group more in the work that they're doing, so that we're aware of what changes are coming and we can make that change sooner to the system. So we're probably making use of AVEVA to support our engineering. We're probably in a matter of 6 months, to get updates into the system.
Great, thank you.
Thanks. Hi, Larry Megan from Lindy. I have a question for Brent. So for Shell, do you have in mind sort of I don't know what I want to call it, a job profile of the operator of the future? Have you defined what you want your future operators what their capabilities should be, and are you working towards that?
Yeah, that's a good question. I'll start it and I'll pass it over to Graham a little bit, so I'll give him a little heads up. A couple years ago, we looked at where the gaps we thought were in our operators in terms of just performance. And what we did is we went to a variety of experts across the organization to say what distinguishes the best operators from the average operators. And really what it came down to not technical skills. Shell folks are really good at technical skills. It were behavioral skills. So we worked together to build a competence model that would make we could apply to novice operators and then what we called great everyday operators. And I'll turn it over to Graham because he did some work with that.
Yeah, sure thing. So as Brent mentioned, what's the job profile of the operator of the future in an industrial environment? And as he mentioned, most of the operations staff at various facilities globally, no matter what industry you're in, they have the information they need in some way, shape, or form. In some cases, they may or may not know where to find that information, and or they may or may not decide to seek it out. So in part of the building the job profile of the operator of the future, what we look to do is consolidate information from operations, maintenance, and the learning environment and put it all in one integrated environment, really one source of truth. So as we build one source of truth and integrate those 3 operating environments and learning environments, then we can make that information accessible to people, and we can start to understand what they are and are not doing with it. And then we use that to guide the job competency profile of each one of the operators of the future, and then reform the competency framework that we apply our simulations to.
I am Bob Whitaker with Shell. I have a question for Shane. So the question is, after you've implemented this new approach to lifecycle management in your safety instrumented systems and you're learning through ongoing operations, at some point in time you're going to have to go through a review of hazard scenarios and a re-HAZOP, if you will. So what kinds of things are you learning now that you might think would be questions or learnings that would come out in the next HAZOP opportunity?
So one of the things that we historically didn't do was initiating event summing. So you may have a level safety high that is being used as a barrier in 5 or 6 different scenarios, and calculating the SIL level of that function. You typically, well, in the past, we wouldn't take credit or include in that calculation all the other demand scenarios for that device. So what SLM allows us to do is add those up and see what our true demand frequency is and incorporate that. So what it could result in is a requirement that we increase the risk reduction factor requirement of certain SIFs. And also we're always fine tuning our depths and standards. If for some reason we adjust our risk tolerance or what our standards are, the global modules in SLM allow us to make that change and push it out globally to see how changing our depth or our tolerability criteria can affect our existing SIFs. So we've done it on Perdido and found where legacy depths versus new created some issues with the strength of some of our barriers.
So I want to bring Jake into that conversation because you're a developer of tools that help to implement. How is it that a company like yours could build the tools that make safety systems get better managed? Can you give us a comment on that?
Yeah, absolutely. So we definitely go by the voice of the customer when it comes to designing, developing tools. All of my operations teams are TUV certified, so we get them through the functional safety training that is required for competency level and actually doing the work that these engineers are doing at the sites and the facilities and the business units. So we really work very closely with the customers and what they really need in order to make the life cycle work, because what you see in a lot of software and technical is very driven by the actual software developers rather than the actual experts of who would be using the tools. So yeah, we work very closely in understanding not only what is required to actually do this engineering work, but how it's actually used in industry. And to add to your question as well, with feeding back into once you have all this performance data, and then you're going into a reevaluation of either the HAZOP or LOPA, not only can you look and see the performance of those barriers, but also if you do have a higher demand rate on certain barriers, then that can make you relook at the initiating cause frequency of those scenarios as well and be able to adjust those. If you're having higher demands on, let's say, a safety instrumented function, well, there's typically other barriers in place before it gets to that function. So it can actually make you look at, okay, what are the associated upstream barriers that are now failing? So is it the operator alarms are not going off? Is it the operators are not responding in time? Is there process or is there design flaws within the basic process control system that is increasing the demand rate of these functions, which should rarely actually be initiated or demand should actually happen on them. So unless all this data is connected in some way that you can visually see, and the calculations are actually happening where you can see what is the expected demand rate compared to the actual demand rate, you're not going to get that level of data to where you can do an in-depth analysis whenever you're doing that reevaluation of the HAZOP or LOPA.
I have a general question. There is a consensus in the community now that safety and cybersecurity need to be addressed holistically together. So that's a very strong consensus as we speak. So I'm kind of curious how you address as part of your training program and things of that nature in terms of raising the awareness that safety and cybersecurity are kind of a part of the whole same conversation.
Let me just start on that. Last year, we did have a speaker who was outlining a program that was building in a training program based on a cybersecurity attack. In other words, you would have a simulation that included a cybersecurity attack. And it became the operator's responsibility to be able to detect that a cybersecurity attack had in fact occurred. This could be, a very difficult thing to do when you have a very sophisticated attack, like, for example, the Stuxnet attack was a very clever and sly thing that very carefully made sure centrifuges failed only one at a time, very hard to detect. So it could be very hard, but nevertheless, cybersecurity training could certainly be part of the simulation program and probably should be. Obviously every place has a cyber program. Now, maybe we could get some other comments from somebody else.
Yeah, I just say it's for me, it's simple. It's just like safety is our license to operate. Cybersecurity is our license to go digital. Okay, so we try not to do anything from a learning perspective or an integration perspective that we haven't gone through information risk management or anything like that. So we're really, even the things that we're doing with our external providers, we find that they have gaps in their cybersecurity. So that's one of the biggest things we're looking at now. So that's probably our biggest struggle right now, is not inside, but connecting to outside.
Yeah. And in terms of training, cybersecurity is important from the top down as well as the bottom up. So in terms of designing and developing learning programs for operations staff at industrial facilities, for instance, you need to have people that understand how to operate things manually. If they're facing a malicious intrusion, then they need to understand not just how to operate in auto all the time, but how to recover from that, how to take things in hand and move things properly to actually operate the process. The same holds true for black plant operations. So, in the case of this sort of malicious intrusion or cybersecurity attack, where the plant could go down, one of the things that you can build as part of the simulation is that black plant startup. The no information, no screens, fully manual startup. And we have clients that actually have that as a requirement as part of their license to operate it, as Brent said. So, it's handled from a top down in terms of giving yourself a license to operate, and that license to operate actually also includes training the people to be able to respond to a cybersecurity attack.
I'm kind of going to try to answer the question too, although I'm not a panelist here. So one of the things when Mangan SLM was chosen for Shell Deepwater wasn't just because of its functionality. We put the extremely rigorous cybersecurity evaluation, and that's kind of how we do everything, because that's our barrier. That's one of our barriers. So if it's susceptible to a cyber attack, then that barrier is not effective. And so everything we do is sort of in that light.
And also to kind of go into what Brent's presentation around resources and having the right people for the right jobs to make the right decisions, I think it's going to be, when you're talking about information assurance, a lot of the times you bring in people that have experience with hacking, right, to actually execute the penetration test. So I think it's going to be important to get the right kind of red hat cybersecurity people in that can test the strength of these systems to make sure that we're preparing for any kind of cyber attacks that can happen in the future.
Michael Hoteling from ExxonMobil. I guess I would look to take the conversation on cybersecurity a little bit, maybe closer to what Shane was working on. When we are doing SIL level and monitoring real-time plant operation, right, in terms of the availability or demand on it. If I think about cybersecurity or where we're going, let's start to get into, what are the demands on network control points and firewall rule changes, et cetera, that have happened in order to keep, your safety instrumented system or SIF truly protected from an outside source. Any thoughts or comments from the panel on, in terms of, is that an area that anybody else is concerned in terms of getting that real-time information, particularly for these SISs?
Yeah, that would be something typically the IT or PCD security guys would look at. As far as what we would look at in the safety side is you would have to assume that any cyber attack would render your control functions inoperable. So you couldn't realistically, expect that your safety system will be functional as designed if one of those demand scenarios happen. So yeah, it's something that if they're not, they should be looking at is the number of attempts and the number of demands on our firewall or safety system. Currently, even with the integration of SLM and process data, it's all on the business side of the land coming through the DMZ. So, and it has been vetted through our IRM system. So none of the data that we're sending or getting back from SLM is critical or any confidential, and it's not touching the PCD domain at all. So, that was vetted. But as far as doing the same type of risk management for cybersecurity attacks, it's something that we definitely need to be looking into.
So I want to make a few comments on that because, in some of my previous work, I had system administration overloading Triconics PLC, triple redundant systems. We know about some of the Triconics, issues here. And then we see also a world with IoT sensors and embedded systems. And I went to an embedded system conference and they basically, we don't even write functional requirements. Cybersecurity, we didn't even consider that. It's not even a requirement for most IoT devices. So clearly, when you are a system administrator of a triple redundant, safety system or even the DCS system, you obviously have to, first of all, trust those people that have the configuration files that are coming off of an engineering PC and getting loaded in there and configuration control all of these issues. Typically, obviously you see several of the companies that were here had, data diodes. These systems are not connected to the internet. The operators typically, and the control room operators, all of the DCS panels are on a system. The DCS is completely isolated from the internet. You can't get email. You can't go web surfing. There's great care to try to keep that isolated. There's a separate set of displays that might have something like OSI Pi and trending, and the operators can use their email on those. So you can see clearly that the critical devices that move critical valves must be a highly secure system. And all these great new IoT devices, it's fine to be able to collect data, but you have to be most careful when you're thinking about the valves and final actuators that they are manipulating, because those are the places you should trace back all of those critical actuators back and make sure there is just no path to an outside source. But you still have some vulnerability,
Yeah, so I just want to add one last thing here, I guess, to this conversation. And if you think about protecting against these sort of things, I think one thing that we can be sure of is that we still don't know what we don't know, and this is a landscape that's constantly changing. And as we move forward, one of the best ways that we can find out what it is we don't know is to simulate the experience of these types of attacks. So, if we expand the thought base of what is simulation. Simulation is an activity by which we replicate an experience. And we can do that in a host of different ways. So as we replicate that experience and we connect and attach things to it and provide proper communications, people start to understand the actual risks that are currently present, and then they can start to get their head around the risks that could be present, and you can start to validate against those things. So, it's a constantly changing landscape. You have to continually assess risk and measure your effectiveness against it, and then you can start to improve, but it starts by understanding where you are in the first place.
Any more questions? I do have one more question from Brent, because he was very focused on the human issues. I was in a facility not too long ago, and I happened to be there at the moment they made a simulation of a man down. So this guy pretended to have a heart attack up on the second deck of a distillation column, and they had to call in the real ambulances, the real fire trucks, and they had to supervise the person, the field operators, to make sure they cordoned off the area and coordinated who had access and make sure there was no drones there just to take pictures, things like this. Brent, do you have any comments on how you train a little bit more on the human side? I know you've been responsible for organizing training simulators throughout multiple shell organizations, but is that part of some of those trainings?
Thanks. Yeah, we've got a model that you look at, how centric the learning is to the individual. Is it adaptive and personalized to them? So kind of do we get it smart enough that it knows it's Ian Willits and, this is where he's at today, and it can just answer the questions and he can basically interact and take it where he wants to go or where he needs to go according to work. Then what we do is we have what we call emotive learning, because we know from a behavioral perspective, there's a chain of custody to get somebody to behave. And it starts with getting them to actually pay attention and listen. Then it moves up to engage. They're actually engaged. Then it moves to participation. Then it moves to they actually believe it and value it. And once they value it, they'll execute it and then they'll model it. And that's what we go for. So I have a hierarchy of taking an individual for behavioral purposes at Shell through that level. And those are very difficult levels to get people through. But scientifically, from a research perspective on cognition and neuroscience of the human, we know that's what they have to go through. Most companies, and I say most, almost all, don't have that kind of capacity to take people to that level because they just don't put enough science into it.
All right. All right. If we don't have any further questions, I think we had some fabulous speakers and panelists, and would like to give them a hand. And